Our next speaker is Homayoon Kazerooni, Director of the Human Engineering Lab at the University of California, Berkeley, and the CEO of US Biotics, where he develops exoskeletons and the like.
Thanks. Thank you so much. Thank you. Thank you so much for inviting me here. It's a pleasure to be here. Actually, the name of the company is called SuitX. It's a new name, actually. US Biotics is an incorporated name. What I want to tell you about is, actually, this was a TED presentation I had last summer. But it turns out behind me, the stage fell over me during the presentation. And I was stopped, and then they fixed it, and it didn't work well. So it was never published. So it never posted. So I decided, I was waiting for a long time, and now this is a great opportunity. So you're actually watching something I practiced. I hope I can still remember it. But please be kind with me on this. So I hope nothing falls here. I think I'm pretty safe here. Right? So you have seen a lot of movies, right? A lot of movies on science fiction movies about people who wear robotic devices and they become very strong. Probably you have seen Aliens, which we started like a long time ago, 25 years ago perhaps, or 20, and then The Edge of Tomorrow, and perhaps Iron Man, which is really internationally well-known movies. They're fantastic movies here. And I'm going to get back to this, but I'm sure you have seen them all, right? Most of you at least. But every one of you here, you perhaps have family members who are doing labor work, perhaps working on construction sites, working in the factories, working in sort of delivery services, all kind. Of course, my job is really easy. I sit in front of a computer and I basically do a lot of analysis, or whatever I do is really sitting in an office. But there are a lot of us that put their bodies into abuse and doing a lot of hard job. And I don't really have to explain those, but you probably have seen on every country, every culture available. U.S. Department of Labor says that back injuries and knee injuries are considered ranked as number 1 and number 2 injuries among workers. And the cost of that goes all the way to $16 billion a year at least on work compensation. Of course, we have lost days also and other costs coming along with that. And of course, in addition to those people I mentioned to you, there are first responders who do a lot of difficult jobs. And of course, nurses move around heavy patients. That's a very difficult job. And in fact, nurses have also high risk of injuries on their back. And nevertheless, you can also know soldiers carry a lot of equipment with them. And they have been reported a great deal of injuries, but just moving these mass of heavy objects, right? So these are people that most of us are familiar with. I gave you some pictures. Soldiers, I talked about workers a little bit, nurses. And it is not difficult for any of you to extend this plot a little bit farther. And you can see elderly comes later, that they have difficulty doing different jobs. And of course, on the very left side, you see disabled people who have absolutely no ability whatsoever to even to walk or do a simple tasks. On the right-hand side, you see soldiers who are quite capable and doing things. So the entire horizontal axis shows a spectrum of all kinds of workers. All of us, parents, children, everybody has someone who do physical jobs throughout their work. They fell through, I guess they didn't make it to become office workers. So as far as elderly and children, again, I don't have to remind you, there are a lot of people with mobility disorders, some because of aging, of course, and disease. And unfortunately, some of the very, very young children are victims of different conflicts around the world. So this is my very simple slide. I just put down 5 categories, and I'm sure that can be huge these days. So I apologize. I'm just giving you a little bit of a snap of people who work difficult jobs, right? So these are not inspiring me. They are not inspiring my staff or my students. These movies are great. They're fantastic, right? But nevertheless, what inspires us to create technology and devices where people are not this. We're not interested in jumping over the building. or go very fast around the world with 20 minutes and basically save a girl's life or perhaps something else. These are all like science fiction movie writers, great jobs, entertaining. What inspires us are people who work very hard, or perhaps they have all kinds of mobility disorders. And I put some pictures for you here. SuitX, or the company we put together, I'm actually a professor at University of California, but every now and then I go out there and I'll do some sort of startups here. This is our company we just put together about 4 or 5 years ago. And the whole idea is to bring robotic devices to these people. I'm sort of the opposite of Dr. O, as you brought up. Autonomous robotics. We're not really replacing a person with a robot. You know, as he mentioned very elegantly, it took like so long to get the robot to come and save us. Here we're trying to equip people with technology to become more capable of what they used to do. So, and also the most important one, it had to be economically feasible. So, and that's very challenging because you have to create a function almost out of nothing because the cost had to be so low that we have to go out of our ways to minimize sensors, minimize computers, minimize cables, all that stuff that we have learned on standard robotics, they stay in the laboratory. We want to get out of that and bring this to people at a very low cost. Of course, that means creating something out of almost nothing. It has a fundamental science. It requires that. It requires some basic challenges that we have to work this out. And of course, once you do that, once economically inspired robotic devices are built for these people, we are able to reach people. And we continue that, and I'm giving you some examples of what SuitX has done. Rather than making a robot, basically here we're making something called Trunk Support Exo, which basically you wear that, and then once you wear this device, it minimizes the forces at this point, L5S1, at the very low bottom that actually most of you realize that. It reduces by 60%. We have done a lot of experiments. In other words, what this machine does, it does only one thing. As long as you're walking around, you can drive with that, you can do anything you want, it does nothing. But as soon as you start to go down and pick up something, or you go to a wrong posture, it becomes effective and minimizes the risk of injury. In other words, we're trying to solve the problem that the Department of Labor addressed that, and it is costly for economic across the world. Here's an example of one of the workers in one of our trial. Here you can see he's moving around these cement bags, and you can see how there are 2 actuators on the side of the hip, and basically allows him to do this job for a long period of time without actually risking injuries. Here's another one. Construction workers are holding 2 beams in this really absolutely bad postures. This is taken in Japan in one of our trials here. And you can see I won't be able to do this thing by myself or with another person for a long time. My back would go away, but these guys have been able to really hold on this beam for a very long time while another person is actually doing some measurement or some propping. This is another person in a foundry area. Basically, it has, as you realize, it's such a wrong posture, and he's able to hold that grinder for a long time without feeling the weight of the grinder. This is another one in Japan in a shipbuilding industry. You can see that he's bent for a long period of time vacuuming. And I highly encourage you to do that. You start to vacuum on someplace very low ceiling and start walking around, and you realize that won't take you more than a minute or 2 that you will see very tired. This is Narita Airport. Here you can see we tried our TSE, or Trunk Support Exoskeletons, that you can see these guys maneuvering objects, again, in the wrong postures in different airports. On a second disease that Department of Labor bring this up is about knee injuries. We started from the back injuries. Now the knee injuries is another one that Department of Labor announced as number 2 injuries among workers here. Basically what happens, because of this wrong posture, they're squatting for a long time, and they do all kinds of jobs on the floor. Then eventually after some time, there is because of the frequent squatting, there is a deterioration of the knee cartilages. And eventually after some time, it reaches to a disease called osteoarthritis. We made another one called Leg Support Exo, which has basically a leg around you, and there are 2 actuators on the side. And basically, again, just like the other one, it doesn't do anything, but as long as you squat, it reduces the contact forces as your knee, and you're able to squat for a long time. As you guys know, squatting is actually a form of exercise. You know, standing like this for a long time is really impossible. And I won't be able to actually hold that, even though I have practiced it more than a minute or something like that. But with this machine, people are able to squat for a very long time. Here you can see this gentleman is squatting and able to hold this beam. And of course, you can have the entire leg support and trunk support together. You can come up to a complete exo for workers in a shipbuilding industry. So, what are the users of bionics here? You can see all kind of workers, and I just gave you some examples. This presentation can't be too long, and I can give you the spectrum of the work. And it's interesting. In every one of those, which I actually practiced them all, the weight of object is really not that high. We are not picking up heavy objects. It's all optimized to be very low. It's a wrong posture. Just bending and doing things throughout the day, 8 hours or 10 hours a day, and depalletizing, working in different industry is by itself very damaging for your knees, for your knees and your hip, and also for shoulders, which I don't have any presentation today for that. So what we're doing here, the fundamental issue of the new robotics, is we are integrating the intelligence of a person, the adaptability of a person, ability to discover and make a decision with some machine that has endurance and strength. That's it. In other words, we're not forgetting people. We're actually equipped them with simple technology we have, which is basically aluminum, machineries, mathematics, you name it, actuators, algorithms, whatever we learn in engineering schools. We put them together, and that provides, this is a cartoon to show the concept here, that shows creating a better quality of life for all of us, for all of the workers, or perhaps people with mobility disorder. And that takes me to my next slide here, which shows the same technology, but of course different algorithm and different hardware. We have used this for moving paraplegics, people who have a spinal cord injury and they cannot walk. I can't really fix the spinal cord injuries, and hopefully someday we will. But with this device, we are able to keep them upright and mobile and postpone the secondary injuries that might happen to them due to prolonged sitting. So this machine is called Phoenix. Suit X is manufacturing it as of March. It's the lightest machine available. It's 27 pounds, and the price tag for that for the consumer is no more than about $35,000 to $40,000, which is a great deal comparison to actual robotic devices that they cost by far more than $100,000. It lasts for about 8 hours of a battery, and allows the person to be upright and mobile. And of course, the most important element of that is modular. That means it's got the hip, it's got the knee, it's got the foot, and the practitioners can choose and pick different elements according to the particular conditions that they have. Here it shows the patient puts these legs together. He's putting it on himself very independently. He's a T12 patient, injury that happens right about the belly area. About 15 years ago, so you can see it takes about a few minutes to put the legs together, and then once you put the leg together, he's putting the torso together. This is very early systems, and of course it's it won't take that long to make this thing even lighter than 27 pounds that we have. And basically he will be able to walk around. It's not very glamorous, but I wanted you to know this is better than sitting on a wheelchair for a long time. And more importantly, if we show this technology to young people, there are a lot of young people here in different universities here, they will be inspired to do more of these in the future. I'm going to go forward. So, going back to our beginning slides here, you can see these movies actually give a wrong impression what the machines do for you. Every time somebody says, what do you do? And I tell them that, they say, oh, have you seen Iron Man? And I feel really bad about it because, yes, I have seen Iron Man, and I really felt bad when I saw the movie because these movies, I apologize, these are quite entertaining, but they really teach nothing but the violence. But these are inspiring. These are people, workers in construction sites or many, many places, and of course, people with mobility disorders do that. All right, my time is up. Basically, I'm recently working on pediatric robotics that we are nominated to as one of the top 10 finalists of the UAE Robotics for Good. Hopefully, we will win. We don't know. But the whole idea is to make devices for children with CP, which they have a very short window of time to learn walking, almost 18 months. And that's our commitment, to bring these machines for parents to actually teach their children that they have no say in what happened to them when they were born. So we have received Series A. We're looking for partners internationally. We're looking for funding, of course, and of course, sales, marketing, everything. But the most important thing we need in SuitX is people with passion. Thank you.
I took your point about making something from nothing, and indeed, compared to robotic systems, $30,000 for the paraplegic system is really very cheap. For some of the other devices you were showing us, the leg support and the trunk support, what price point do they have?
Very good questions. The industrial support shouldn't be anything more than $4,000, $3,000 with a life of about 4 years. That will be the situation that the employer would be able to buy those with that price. We know the price is high a little bit. It still is high for construction environment. But as a researcher and a founder in these, what I go and I tell my staff, my students, everyone is, hey, we want to do this stuff, but I also limit them to use many of current technologies that are already available because it actually adds to the cost.
Yeah.
And we in academic, we're sitting in an ivory tower, we want to make all kinds of beautiful things, which is really nice. But we shouldn't forget that there are a lot of people out there, they want our technologies yesterday. You know, when I see children with CP coming out and they can learn things, and we have all that technology, Dr. O showed you, all that sophisticated stuff is out there. Why can't we get that technology for children and teach them how to walk when they're age of 4 years old? And that's the rush. That is the passion to create something for them, but try to cut the hardware and have more emphasis on the software, which is lower cost, but provide to give them minimal and create something almost out of nothing.
Do you have a price point you're driving to for both CP patients and for industrial use?
Very good question. For children, we're thinking about $10,000.
Yeah.
Very light machine. We already have prototypes. Unfortunately, I didn't have time to show you, but I can talk to you offline. Industrial machines shouldn't be anything more than $4,000 to $5,000. And of course, for paraplegics, probably $30,000 or $40,000, which are the prices of a powered wheelchair.
So I'm going to take some questions from the audience, but if you're forcing your researchers and designers to work with stuff that's essentially already in industrial use, and they can't use any of the nifty stuff that you have in the lab, what things that are currently in the lab would you long to see industrialized and commercialized so they can be put into your products?
In the future?
In the future, yeah.
Well,
what would you like to see the price point come down on? If you could wave your magic wand today.
I honestly think the price of, for example, the price of a device for a warehousing situation shouldn't be more than $2,000, considering life of 3 or 4 years, and then you can refurbish it and sell it again. Well, we're about $4,000. We are half there. And also, as a founder, I have a responsibility to start it somewhere. We just can't wait until once you start it, new generation will come and bring the cost down. Like cell phones, it used to be big and bulky and expensive, but nowadays almost the cell phone itself is actually free in comparison to the services you get. And the same thing here. We're starting this up as an economically inspired robotic devices, worn for people to create a better quality of life. And we're not there yet. And that's what we're doing, fundraising more and more and more, as much as we can, to bring this technology within 5 years to people at the very low cost system. I'm confident we can do that. We already have sold some of those at the price of like a $5,000 or $6,000.
Let's take a couple of questions from the audience, if we may. Raise your hand, say who you are and where you're from, and this gentleman here on my right, please. And questions are better than statements, more polite too.
Hi, I'm Lawrence, Asia Pacific Technology Network. My question is, what breakthroughs would you like to see in energy technology? Because, I mean, if the battery life is only 4 hours, 8 hours, if it runs out or shorts out, you're stuck with 27 pounds of dead lead weight.
Did you hear that?
I think the question is, what breakthroughs would you like to see? Did I understand?
In energy technologies.
Energy technologies. So, yeah.
Very good question. Obviously, we always need batteries that last longer because we don't have much of an energy that we don't even have, right? So that's like, for example, as far as energy concerned, right now we're giving 8 hours of intermittent walking, 4 hours of continuous walking. So it would be nice if it can come up to like total 1 day at least, and then eventually becomes 2 days. The question of stability that was brought up with Dr. O is very valid here. We don't want paraplegics to fall. These are another bottlenecks we have to work it out. Energy is another one we have to work it out. And also bring the weight down as much as we can without adding cost, right? As soon as I say make it lighter, everybody says carbon fiber. Well, we know that. But that's also expensive. The carbon fiber bike is expensive too, right? Is there any way we can do something a lot more clever to bring the cost down for people who actually need that? I had a couple of slides on children with CP, and that really has made me quite actually busy these days because, look, children is our future here, right? It knows no boundaries. It doesn't matter which country you are from. And these children who have neurological disorders and they can't walk, right? They had no say in what happened to them. And parents don't have money. Insurance companies don't have any codes for them. And guess what happened? After sometimes they can't walk and eventually go to wheelchairs and they get withdrawn. So if you can create all of that stuff at the earliest stage with low cost and accessible, that means creating something almost out of nothing. It would sell. It's a big market, So that's what I'm pitching here.
On the gentleman's energy question, why can't you harvest energy from the user's own motions using piezoelectronics or?
Excellent. In fact, we do. In fact, during walking, walking is a rhythmic maneuver. Every time you have a rhythmic things, go, stop, that's an opportunity to get some energy back, like automobiles perhaps. We do the same thing on the walking. We walk as you walk during hill strike. When you hit the ground, you slow down. You get some energy absorbed, goes back to a supercapacitor or whatever we have. So we do some of those, but those are still, it's going to be improved more and more. And that's what I'm excited because you're right, the energy harvesting that you brought up here is an issue that we're doing it at the knee. We're not getting it much, but I'm sure if it happens, a lot of people would be inspired to actually add into that 2 years from now.
Well, I was inspired. Homayoon, thank you very much.
Yeah,
I enjoyed that.
Thank you.
Thank you.